All right, so I think this is recording. Let's take a look at these application problems. Here we can make a sketch of a right triangle so we can see what's going on. We've got an angle theta. If the sine of theta is zero point 0.6, then I can just think of the opposite side of 6, and the hypotenuse is 10. And most of the time, previous to this, we have been trying to define that ratio. They give us the angle. Well, now they're giving us the ratio and asked to find the angle. So we are finding using the inverse sine function. This -1 does not mean 1 over sine. This is the inverse function. And on our calculator, we'll first, it tells us to be in the directions to be in degrees and to round to the nearest thousandth, so that's 3 decimals. So let's come in and change it to degrees, go to the nearest thousandth, to the third decimal, and if I'm trying to find the angle here, on the TI calculators and even on most of the Casios and stuff, you'll hit some second key that allows the buttons now to act as the face that's on the calculator. So you see that sine button there. Since I've hit the blue key, and now up above there, well, it's hard to see on the screen, but is sine inverse. So it's the sine inverse of 0.6, and 3 decimals, they're telling me that it's 36.870, and I need that degree symbol. So there's our answer for number 1. So again here, if you're thinking about right triangle trigonometry, and 75 over 100 would be a similar triangle to anything, the cosine, the adjacent leg over the hypotenuse. We really don't need this. I'm just drawing that for illustrative purposes. The cosine of an angle, is this in decimal form? If I really want this angle, I need to take the inverse cosine. And we've already set the calculator up to be in degrees with rounding to the third decimal, so we can just key it in directly. We've got the inverse cosine of 0.75, and we have 41.410 degrees. So if the sine of angle theta, this time it's not as a decimal number, and I can, by similar triangles, I know whatever triangle that might be in reference to would have the same ratios as this one, that would have an opposite leg of 1 and a hypotenuse of 3. So if they give me this and they're asking, we think of this as input and the 1/3 is the output. Well, we need the input to be -1/3 and the output. So that function, instead of inputting theta into some sine function or any function, we could just call it f, and it's the output being f. We're going the other way. So let's call this like a ratio. Let's call this a ratio. If we want to give it the ratio and have the output be the angle measure, we need these two functions to undo each other to be inverses. So that's exactly what we're allowing the calculator to do for us. So the inverse sine of 1/3, I'm getting that the angle measure is 19.471, at least to 3 decimals. So I don't necessarily have to keep drawing the right triangle. Since we've done it for the first 3, you kind of get the idea, hopefully. And if I take the inverse tangent of 0.25, I'm getting 14.036 degrees. The inverse tangent of 3 I'm getting 71.565 degrees. Now here, we do not have a button that is the cotangent button or inverse cotangent. I know that cotangent of theta and tangent of theta are inverses of each other. So if the cotangent of theta is 3, then the tangent of theta is 1/3. And if I use the inverse tangent of 1/3, then the calculator will give me what we need. And the directions haven't changed. We're still in degrees. They still want it to the nearest thousandth, which is 3 decimals. So I've got 18.435 degrees. Don't forget your degree symbol. That's important. So I don't have a button on the calculator that's a secant. I do have the cosine of theta, and I know that secant and cosine are reciprocals through the reciprocal identity, so I can take the cosine of theta is equal to 1/4, or that theta is the inverse cosine of 1/4, and I'm getting 75.522 degrees is my answer. Now again, I need to take the reciprocal and now use the inverse button on my calculator. And the inverse cosine of 4/5, 36.870 degrees. The cosecant is the reciprocal of sine. So I'll jump to the calculator and let it do the work for me. .757 degrees. Alright, I'll do these application problems on another video. Hope that helps.